Hello and welcome to tonight's Meeting C++ live episode. Our guest tonight is Rainer Grimm, who is well known for giving trainings, speaking on conferences, giving talks everywhere, and his blog, which is very active and has written a lot about the C++ standard. And so, Rainer, welcome to the show. It's a great honor to have you.
I'm happy to be here. Thanks a lot, Jens.
Now we basically get started with your questions, but that usually takes some time. So, Rainer, let me start simply by asking you, what's the last things you covered in your blog and you've done in writing about the C++ standard?
Currently, I'm writing about 20, and I make a deep dive into the Chrono extension in C++ 20, because I would say most people are not aware of what is inside. So I write about time of day, calendar, then about time zones. There's a lot of interesting stuff, Chrono related, in C++ 20.
Yeah, I actually wrote some code with Chrono this month, and I found it quite interesting that often when you search the web, you find on Stack Overflow that there's one person answering the questions, which is the author of the Chrono library.
Howard Tinard.
Yes, and it's sometimes frustrating to kind of get the answer well, if you want to do that, actually, that's available in the date library, which I have on GitHub, but it is not the standard yet.
Yeah, and there's a small pity with the Chrono library, in particular this extension. It's extremely powerful, but also very complicated.
Yeah. That's you wrote about time of day, and that's something I also looked into. Chrono is very good in handling stuff which is basically by definition a time. But I actually looked it up on that. So the answer to that question on the question is about basically what if you only have a time without a day? And this is kind of difficult to represent in Chrono right now. You basically have to write your own implementation for that.
Okay.
Anyways, let me see if there are some questions for Rainer.
Let me add one small remark. What is also nice is the interplay of Chrono with the format library. You can nicely display the values.
That is true. Generally, I think, Chrono is very thought out, and the user friendliness is not always there, in my opinion. It's kind of hard to get a start with it, and the duration.
Exactly.
And if you just want to deal with something which is easy, I've pondered about just converting to struct TM instead, when you just need the values and not do complex calculations or something or time zones. So you said that you covered C++ 20 currently, or that's the current work. How much have you looked into C++ 23?
Oh, C++ 23 is not as big. Meaning, I wrote essentially, only to give a rough number. I wrote around 10 posts about 23, around 100 about 20, to see the difference. So on the core language, you have one extremely nice feature. This is deducing this, which enables pretty smart techniques to get rid of, for example, CRTP. On the library side, you have interesting libraries. Stud expected, monadic extension of stud optional, then MD span, multidimensional span, what else?
So do you have C++ 23 already fully covered on your blog?
I would say I have it at least as much covered as readers should know. I don't go in each detail. And still, many features are not available. For example, flat map, flat set. I'm really curious about the performance numbers, but so far, none of the big three implements them.
That's true. That's true.
I still wait and want to compare it with a map and another map because I'm really curious about performance.
I've looked into CRTP recently, and deducing this seems to be really nice for that.
Exactly nice.
But it's not implemented in GCC right now, and I'm on 13, and I have no plans to change to 14 right now.
There's also the so-called overload pattern to get rid of the design pattern visitor. And this can be done really, really nice with using this. So the visitor becomes very, very easier. And let me say, do you know what my favorite feature is probably? Import stud. You can just import a modularized version of the entire standard library. This is so nice, in particular for beginners. You don't have to think, is this algorithm in functional, in numeric, or in functional, numeric, or an algorithm?
You basically get rid of all the headers, right?
Exactly.
You have like the whole standard available, and you don't have to think
Exactly.
like, what do I need to include?
And you say only import stud. This is all. And with Windows, you can already use it. I think this is a very nice feature for beginners because they often forget to include the needed headers. Or sometimes you don't include it, it works on Windows, but it breaks on GCC, or the other way around.
Yeah, I think like modules are still far away from being like portable.
But
and Windows is certainly ahead.
But it's not a question, because now it's not in the responsibility of the developer. Now it's the question of the compiler builder. Now therefore, I think this is an extremely nice feature. Just say import stud. This was it.
Okay. Let's go from the realm of standards to a question about threading. If you want all threads in a system to sync on the same clock tick, do you recommend sharing one SED chrono object between all threads?
I'm still thinking about a question. When you want to have, let me just give you my thoughts. When all threads should follow one clock tick, you need sequential consistency. This means all operations of all threads are performed in the same sequence. There's no, this is one of the guarantees of sequential consistency. Therefore, I don't see your question about stud chrono. I see more the question about the memory model. And when you want to have an explicit point in your program at which all threads synchronize or wait, use a ledge or a barrier in C++20. So I would think about it in a different way. Establish, for example, a synchronization point, say ledge or barriers, or use sequential consistency, which gives you the guarantee that all threads see all operations, all atomic operations, the same sequence.
Okay, yeah, I agree with using a ledge. Let's see, there is a question. Let me copy it here and make it a banner. All right, so in the past summer, I read some books and worked the examples about coroutines. Of course, one of the books was written by you. Coroutine is another word. I think that's the word. So
Yeah.
we will have a talk on coroutines next week. So, but you've written extensively about coroutines too.
Let me say a few words about coroutines. It took me quite a time to get them in my head. I need a few iterations, at least starting in 2018-19. It's really, really complicated, but on the other side, extremely powerful. In general, when I teach coroutines, I show examples, put output inside these examples to see the workflow of these coroutines, which function invokes which functions. Because under the hood, coroutine consists of 23 functions, which you must partially implement. 23. And this defines the behavior of a coroutine. But when you do it a few times, play with it, change it, see what happens, you will get intuition what you can do. And this is powerful. For example, I wrote once complicated, or let's say advanced schedulers for coroutines. I achieved it, but I did it in 5 steps. And then I had it. Meaning, even I, which I'm not a total expert in coroutines, I can achieve such tasks because it's doable. But anyway, you're right. It's another world. And it's a pity that we don't have a coroutine. The only thing we have in 23 is stud generator, which is a kind of an infinite data stream. So once more, do it a few times, dive each time a little bit deeper, and study the examples. And then it will make sense. By the way, Jens,
Yeah.
who will talk about coroutines next week? Andreas?
Andreas Fertig will give a beginner talk for coroutines on Thursday, which I'm looking forward to. It's been a very popular topic to write about. There's like so many blog entries from you, Bartek, and lots of others. And
what's also special about coroutines? Each one, how should I say, addresses them in a different way. You have to learn what's your intuition about coroutines. For example, Andreas talks about a state machine. For me, it's a framework of function which will be performed, and you can adapt it. So it depends on your perspective. and you have to find your own.
True. There's actually a first question from LinkedIn. So, hello to LinkedIn. George asks, how can we convince the company to change the C++ version? For example, like from 17 to 20. What is the most important argument, in your opinion?
This depends on your use case. But in general, do something optimization-like, meaning this is now faster than that when you switch from 17 to 20. Because optimization of performance is always the key argument. But once more, it depends on your use case. When you are, for example, do a lot of concurrency, C++ 20 is way better. When you do a lot of financial things, you may be a big friend of coroutines. So it depends. When you play with generics, go to concepts. This makes your code way, way more readable, way, way more understandable. But in general, it depends on your use case. But anyway, 20 is at least as big as 11. There are many reasons to switch to 20.
I think one of the arguments also could be that code generation gets better, and other things like when you need to communicate this upchain, features might not be the big thing, because except from bigger things, which modules. If you can utilize modules, if modules can make your builds faster, I think that modules are a great argument to actually say our build time gets better, and then that raises productivity. And so that would be a very strong argument for people to actually put this through the company.
But modules have now their issue. How will you port them from one platform to the other? Maybe on Windows you are fine. So I see this critical with modules. When I give a 20 class, all of them want to know about modules. Afterwards, they said, it's a little bit too early for that. So I see modules critical. 23, import stud is great, but modules in 20, we need tool support here.
Yeah.
Which is coming.
It depends on like there's like the question is not that easy answerable when you don't know like what tooling you use and what platforms you target. Like, are you in embedded? Are you under Windows? If you're under Windows only, I think the argument for modules is already there.
Exactly.
And
I totally agree.
To make a experiment with Clang and GCC to see what you actually can achieve, and also like try to argue that like getting the standard library as a module in 23 is already available on your fingertips in Windows.
Just totally easy.
And then you have place to move to the newest standard.
You only compile it once, and then you can use it. And of course, the build times are unbelievable. Around 10 times faster when you switch from an include-based library to a module-based.
Okay.
By the way, these are not my numbers. These are the numbers from Daniela and Bjarne.
True, Daniela has done a lot of work in that field. So there has been a huge topic about C++ in the recent days, and we can't get around asking you the question. So here it is: can C++ shed its image of an unsafe language more so in the context of the White House news or announcement? paper, how you want to call it, to developers to desist from using C and C++?
Okay. Before I say anything, I have to say I'm not an expert here. But when I teach C++, I teach how to use C++ safely. Meaning, of course, you can do things like in C and C++, but this is not how you should do C++. When I wrote my book about best practices, I teach the modern, I teach the safe techniques. And your responsibility is it to apply these techniques. This is for me not a question, is C++ safe or not? This is a question, just use the right techniques. And then C++ is pretty safe. This is, by the way, also the job of me and my colleagues as a teacher. Exactly to teach the rules. Exactly to use concepts instead of templates. Or let me say differently, constrained placeholders instead of unconstrained placeholders. To initialize with curly braces, not with parentheses, and so on and so on. To use, let me put it differently, n, no negative. Use just smart pointers. Use a unique putter. And this is it. So essentially, it's not a question about C++. It's a question how you apply, how you program in C++. So a pretty general remark. And once more, I explained these techniques in my core guidelines book. And I learned a lot by studying the core guidelines. Believe me.
Yeah, I think this. I liked Herb's blog post, which he'd written last week, I think. So that's like the one thing I probably want to point towards is that blog post, which takes this topic very serious. It's very long. It's almost a book. You can spend several days reading that. It took me 3 days to basically read it in sessions. And so I hope that the committee takes this serious. And from her blog post, I have the feeling that they do. But it's not like that we can, flip a switch and have a safe C++. And so we'll have to see how, this evolves. And as Rainer said, he's not the expert on that topic, so we'll see. Maybe we get we get Herb on here, and we can talk about safety all day, and CPP2 and other things. But actually, one thing where Rainer is known for is mentoring and coaching. So there was one question from the audience. When did you decide to focus on coaching?
Honestly, I have an issue with the term coaching. So what I want to distinguish is mentoring and training. Once more, training means the classical way. I give a 3 days class, let's say about concurrency, let's say about embedded, let's say about 20, and so on. In 3 days, I can only touch each feature. Mentoring is something totally different. I make out of this 3 days, 4 months. We do each day, each week, we talk about different topic. This means you have to invest around 3 hours a week. These 3 hours include theory, pre-recorded exercises, examples, pre-recorded in a Q&A and a forum. And now you have to do your work, and each Friday I will answer your questions. And this is now way better. First of all, we can touch each feature a few times. Second, from different perspectives. Third, we can discuss it in the forum, or you can ask me questions. Meaning, this is way more intensive. And you will learn something, not only in 3 days, in 4 months. Therefore, it will stick in your brain. This is the main difference. A lot of stuff is prepared, and I help you to master this. This is mentoring. It's also easier to handle more than 50 participants. In a class, it's not possible. 10 is a lot, 15 is the limit. But with mentoring, this scales. By the way, all is recorded. Therefore, also, when you miss something, you can watch it later. So this is mentoring. And my idea is, but our industry has still an issue. My idea is that your company sponsors you, gives you 3 hours a week and the corresponding money, and you just participate. And you do it beside your usual workload. This is my idea. Because what we must learn is that learning is not one step, this is a process. And I'm honestly pretty engaged in this, because I think this is the future.
It's definitely an interesting format. What is your newest mentoring program about then?
Concurrency with modern C++. This means I talk about concurrency in 16 steps. About the API, about threading, about memory models, atomics, about challenges, about patterns in this domain in 16 hours. And this is my only advanced one. I have 4 mentorings. Fundamentals, which is the base, which takes 32 weeks, in which I essentially explain what you must know about C++, including 17. Then I have 2 mentorings which are based on that. First is design and architecture patterns in C++. The second one, C++ 20. And as I mentioned, the newest one about concurrency.
Okay, so what's something you'd like to see in the C++ standard?
It's a difficult question. I think around concurrency, there's a lot missing. Concurrent data structures, for example. Each company develops its own concurrent stack, thread safe stack, strike stable queue, log free queue. Additionally, what I miss the most is when we have features which are not 100% done. I find this terrible. In particular, we need coroutines, implemented coroutines, not only just to generator. Because what I fear is that in 5 years, each company has its own coroutines. Such as in the past, each company had its own stream. This is terrible. And of course, we need more functionality around networking and all. You see, I don't prepare for this question. More help for beginners. Meaning, package manager, maybe build support, all these topics, tool support in general.
Yeah.
Because I think this is way too complicated.
I think there's a lot of things which are on the way, but the committee is, when you like the latest meeting was in Tokyo just last week, and over 200 people have attended, and there's the first 26 is taking shape. Have you been able to follow the work on C++ 26?
No.
There's a new question, and we are again on concurrency. Do you consider Boost Agio to be valuable in the realm of concurrent programming, or can the same functionality be created from scratch using SDL?
I have to say, I'm not a Boost Agio expert, but Boost Agio was long thought to be part of the standard, of the next standards, networking library. So, can you say something about it, Jens? So I only know that Boost Agio was one of the future candidates for standard, even for 20. But it didn't make it. Boost Agio has also coroutines involved. This makes it also a little bit more challenging. So what's your thought?
I think that Agio is, in certain parts, an industry standard which we have. And when we tried to standardize it, we saw that we need to have the primitives upon which Agio is built first in the standard, and that we do not want to standardize Agio with those primitives and then standardize different primitives again and have like two versions of coroutines or schedulers in the standard. So this is one of the reasons why this didn't go through. But it's on the way. So networking is in 26, probably coming in some parts. The whole scheduling and executor part is coming along. So I think from 26 and moving onwards, staying with the 3-year model, C++ 29 probably will be interesting in that era. Could you implement Agio with the standard right now? Of course. Should you? I don't think that this is a wise option. And on the other hand, I'm also not like an Agio expert, like what issues you have with the Agio implementation, how well it has aged with the new standards. And in that context, it might make sense for somebody to write a fork or to re-implement these things.
Okay, let me add a few additional thoughts. First of all, Christopher, who is the implementer of Boost Agio, adapted or changed its implementation for future adaptation to the standard. So he also did a lot, as far as I know. Second, what was second? I forgot a second. Then it will pop up in a few seconds, I assume. No, let's just continue.
Yeah. Okay.
Now I have it. I don't like it when things are kind of an unofficial standard, but not part of the standard. Then most companies, or at least half of the companies, can only use stuff which is in the standard. This is just it's a common company policy. Therefore, we need such stuff standardized.
Well, that certainly helps, but having Boost in your code base then makes also sense.
Yeah, but many companies, you cannot do it.
Limits the applicability. Actually, there's a question on libraries from LinkedIn. In your opinion, what are the most important libraries for C++ that we need to know in depth?
Let me first give you extremely straightforward answer. The standard template library. The containers and the algorithms, and the iterators in between. Of course, because this is the basis of all. This is what you at least should know. Then I would say making concurrency without a library is not possible. You must know the concurrency stuff. So this question essentially depends on your domain, what you want to achieve. So in general, I cannot say it. But what I always say is you must know at least the basics, which is the containers, the algorithms, the iterators in between, and how to use them using, for example, lambdas or function objects or anything like that. And then you can build high abstractions. Then, when you use the algorithms and you do 17, you can also do it in parallel. Using the execution policies. This is what is a must.
Yeah.
And the rest depends on your domain.
I agree with that. I mean, there's Boost and Qt as the big ones, which kind of, are not so much in certain domains and WX widgets. But then it becomes very specific, and there's a lot of libraries. Which are maintained or not. And I don't know if have you been asked to give trainings on libraries?
The question is, do you mean standardized libraries or free libraries?
I mean, free libraries.
No, but I had a few days ago a very interesting discussion with Qt. In the past, Qt filled the gap which was left by the C++ standard. But this gap is now almost filled by C++ standard. So I asked him, what can Qt do what the C++ standard cannot do? This was very interesting. So things like, what was it? Things like infrastructure library, such as XML readers, security. This is only doable in Qt. Or what was it? There's one big thing missing.
UI.
Yeah, UI, of course, but I only think more of the framework. So what Qt is way more than Qt. It's a framework.
Oh, I know.
It's a platform.
But it's like in terms of standard things which are not covered by the standard, UI is a big thing which is and probably will never be really coverable in a commercial way that would make sense to use it, to be clear here. Qt has a good string class. Qt has a lot of things there which come with its history. And networking, for example, is also one of those things.
I know what I forgot. TCP/IP stack. Exactly, this is what I forgot. For example, when I was responsible for Defi, this Defi should have a server on it. And therefore, we decided for Qt.
Okay. So let's move on to another question from LinkedIn. Emmanuel asks, do you consider code written in C++11 as legacy code due to newer standard versions of C++? What are your thoughts about the minimum C++ standard to be considered as modern code nowadays?
Honestly, this is a difficult question because the answer depends on in which domain you work. For example, I have customers from Siemens which cannot not even use C++11 because of their old chips in their old C++ compilers. When I say you should switch to a modern standard, I would say at least 14, not 11, because 14 fixed a few issues of 11, such as generic lambdas, such as generalized const export. And this makes your life way easier. Additionally, these are the two most important things, I would say, in 14. So at least 14, not 11. Then 17 may be a small step. It depends if you need these features such as parallel STL, such as the 3 new containers from Boost, any optional variant. And then comes 20. And 20 is a big step. The big fear are all change all the way you program. So to come back to your question, at least 14. If you can do it, go to a newer standard, but at least 14.
I agree with that. That you probably should push for a standard that is above 14, but if that's what you have to settle on, that's fine-ish. And like there's like AutoSAR, which partly still is 14, depending on the version. And always there's like, parts where your job is in a certain context where you cannot change that due to being pinned to a compiler, being an embedded or anything else, like where your environment fixes you to a certain standard. The other way is like I want to say that also the context depends on like if the code written in C++11 is legacy. That's not so much the case maybe for code base which is well written. If you're more like needing to write new features, then that should be on a newer standard. Anyway, let me see if there's some more questions. So anyways, yeah, if you have more questions, please put them in the chat in LinkedIn or in Hubilo. In the meantime, let's return to the mentoring, because that's something which Rainer has pioneered in the last years.
Exactly.
So you have 4 programs on mentoring.
Right.
And how does a typical mentoring program, what is the structure?
So each mentoring has 32 or 16 steps. Each step is a week. In each week consists of 3 parts: theory, practice, mentoring. For example, move semantics. In this week, I've recorded the theory about move semantics, which you can watch, consume. Then, in the practice part, I discuss this theory once more using examples. Additionally, I give you around 2 exercises a week, and also the solutions to the exercises. This is the practical part. Additionally to that, I have a forum in which people ask questions which are answered by me or by others. The last point is about mentoring. On Friday, I have 2 mentorings, one at 9 a.m., by the way, German time, one at 10 a.m., one at 9 p.m., because I have people from Seattle and Sydney. So, in this Q&A, I discuss the topics of this week and also the forums questions. And we may go a little bit deeper. And then we may have additional discussions. This Q&As are also recorded. Therefore, you can watch them later. In each week has around one big topic, and this topic can be, let me say, divided in 3 parts. Each part has also a topic or a page, further information, in which I provide additional blog posts, talks I gave in the past. So stuff which gives you more information if you want to dive deeper. So essentially, the minimum you have to invest a week is 3 hours, but you can, of course, invest 6 hours also. When your mentoring is over, because there's a lot of stuff, you can become a community member. Meaning, at this time, pretty small amount of money, you can still consume all the stuff you consumed so far as long as you like. This is the so-called community membership. Because my second goal is to build an active community which coordinates itself using the phone. Because it often happens you have an issue with that, let's say, move semantic, but your program is done. Now you can go back and watch it once more or ask your question.
Yes. That's exactly what you also can do tonight. Ask a question to Rainer Grimm. And there's the next question. I recently worked with a C++ developer who was against deriving from regular base classes. He wanted only abstract base classes interfaces. Do you agree with this restriction?
Anyway, let me put it differently. There are two ways to derive from a class, essentially. Public and private. When you derive public, you want to build something such as an interface. When you derive private, you do something which is called derived implementation. So this is the first thing I would differentiate. Most of the time, you derive public to build this interface implementation hierarchy. Sometimes you derive private. The idea is that the derived class can use the functionality of the base class, but is not a base class. This is the idea of deriving private. I don't see so far a point why you should not derive from a regular base class. What does regular base class mean? Regular means essentially this base class supports the big six and additionally is equality comparable and supports swapping. So what does it mean when you derive from such a class? I would say my first gut feeling is that I would not derive from such a class. Because a regular base class behaves like an int. Behaves like an int is, it's more in value. And a value is something you don't want to derive from. These are pretty, how should I say, early thoughts. But I think they are right. So let me think about it. When you have a regular base class, it has a destructor. Now the destructor must be virtual. So the point is essentially, do you want to have the regular base class as an implementation or as an interface? As an interface, I would say it makes not too much sense. I can also not think about the implementation. So in general, regular base classes should be simple, meaning more like values. Don't derive for them. When you mean regular in the sense, regular is defined in the standard.
True. At that point, we also should mention that there's something called static polymorphism, where you use basically various types and use a variant to join them, and you can also constrain that with concepts. And maybe what's your take on that, on this way of programming, Rainer?
What do you mean exactly by static polymorphism? Please, do you mean just generic, templates-based?
Yes, that plays into this, right? That you can use templates. This is way more template friendly, but
or do you mean CRTP?
that plays that is a pattern which also lives in this space, which is polymorphism. That's true.
So it's static polymorphism. Let me put it differently. Static polymorphism is a little bit strange in C++, because static polymorphism is essentially the idea of interpreter languages baked into C++. What do I mean by that? There's a common term for that, which is called duck typing. This comes from Python. When I see a bird that walks like a duck, talks like a duck, walks like a duck, I call this bird a duck. Meaning, static polymorphism means you implement something and then it may break because it requires addition and your data type does not support addition. This is the idea of duck typing. You just hope that it works, and now it may fail. But now it fails at compile time. Due to concepts, we can make this duck typing in C++ way more stable. But it's still duck typing. By the way, the opposite is dynamic polymorphism, because you have an interface and you can only use the types which are publicly derived from this interface. This is a decision made at runtime, but static polymorphism is made at compile time. And then we have this special variant of static polymorphism, which is called CRTP, curiously recurring template pattern. But this looks really curiously. But when you do 23 with using this, it looks pretty nice. And now when you also combine it with concepts, I think this is pretty nice. Sorry for this long answer.
That's okay. There's a question from LinkedIn on the new languages coming in. What is your take on the ongoing work on Carbon language and CPP front?
This is also difficult to answer. The most difficult point is for me, there are already attempts to make the better C++. D, Rust, Carbon, CPP front. And what I think is the most, one critical point is, which one will survive? And which one gets the most lasting manpower? And I'm not sure if Carbon may succeed, because I know this discussion around 24 about D. Almost no one knows D anymore. This was also the better C++. So I'm not sure how it will go out. I think the most important point is how many people keep this alive? Are there companies supporting it? In particular, with money and manpower? And will there be any interesting projects using this language? And of course, these languages need a mighty library. Therefore, they have to interact in some way with C++. So these are key questions. In the long run, there are way too many people, companies, using C++. It may become a little bit smaller, but only smaller. In the long run, there may be a programming language. I'm not sure if Carbon or CPP front or another one, which is the dominant programming language in the future when it goes about abstract programming on the system. Maybe it's not invented so far. You have to think about how young our industry is. When I studied math. We talked about the Greeks. In our domain, we don't talk about Greeks. We talk about the last century. It's extremely new, our domain. And therefore, there will happen a lot in the next time.
Yeah, I think it's extremely hard to say what will come from those new projects, which basically just are play fields for ideas, which is interesting for C++ again, which then can standardize those good ideas which came out of it. And there's probably also, like, in the future, guests in this show which can say more about this. So there's again a question which goes more.
Let me add one point. Yes. When you just think about how complicated concurrency is, we only know that there's existing solutions in all programming languages are way too bad. This is the only thing we know. We now fight about the right abstractions. May it be transaction memory, sender receiver, post boxes, future promises, coroutines, you name them. We just fight for them. And we don't have the right abstraction so far. We only know that one abstraction is not enough.
No. Is there any case where a class containing only public static functions is preferable over a namespace?
This is a pretty theoretical question. Okay, what does public static function mean? This means each function can be used without an instance. You can directly invoke it on the class. I honestly don't see a use case for that. So to group them together, I would say a namespace is a good idea.
I think it's an any pattern too.
Yeah, it reminds me a little bit to a singleton, but it's a different point.
True. All right, we're now over the hour. Rainer, do you feel like we should keep going, or?
I'm fine.
Okay, so if you have any more questions, post them in the chat, and we'll surely have a lot of more of things to talk about with Rainer. And like maybe just I see this, like, you know, we have had some questions about C++ features. Like what's the most features or topics you are being asked in your mentoring program and trainings about?
This is a difficult question. When it comes to understanding its coroutines, often I give, let's say, in a 20 class, a 2-hour introduction to coroutines. Afterwards, this sometimes was extended to 1 day because I wanted to dive deeper. So I would say in 20, maybe modules and in particular coroutines. Also concepts, so essentially the big four. So let me also name ranges. But from the understanding point of view, it's coroutines. And from the usage point of view, modules.
Someone asks, like, what is your take on Nico users' view on C++ 20 views that they are broken, or generally your view on views and ranges? Do you agree with Nico?
This is also a difficult question because Nico is my friend. But Nico has an extraordinary skill to find these issues, these broken issues. I also wrote about 20. And honestly, I didn't fall in the same traps. But Nico is in this kind a little bit special. He's extremely good. And he finds this 1, 2, maybe 3%, which are really, really error prone. Such as his discussion about range-based for loop. It's a little special regarding Nico. But this is not a complaint. He just sees the issues. And I would say the most users will not see these issues. So he's right, but from his point of view. This was a diplomatic answer.
Yeah, I partly agree with that. It's like Nico's really well, and I have once heard from a committee member that the one thing is like that the one thing they don't like about Nico is that he's usually right, and so I think there's some issues which he discusses, but also I've heard some committee members that it's like the wrong angle, but that's not what we have to debate today. And I'm sure that we have Nico on the show at some time. Then we'll be able to fully go in depth with those things.
But what I totally appreciate about Nico is, what I hate is when someone says, this is bad. But he also shows a solution. And this is what I totally appreciate.
Yes, I agree with that. I see no more questions right now, but maybe there's some more questions coming in. I saw you talked a lot about and have updates on your blog about your RLS journey and do fundraising. And
exactly.
So maybe quickly want to, talk about your activity on this field, like with your fundraising activities in ALS.
Of course, I'm personally involved. You see, I have alias. Therefore, I need something to fight for. And now we start our second ALS money raising campaign, which goes directly into ALS research. You may ask why. The reason is pretty simple. ALS research is heavily underfunded. In contrast, for example, to cancer research. This changed in the last years, but it's still not fine. Therefore, research depends on donations, which is really hard. By the way, this money does not only go to ALS, it goes also in the other issues with the nerves, such as, I hope this is pronounced in the right way, Parkinson, multiple sclerosis. I don't know how to pronounce it in English, but any other of this kind of bad issues. So next Friday, we start our next money raising campaign. And this time, I'm happy to say, 4 of my colleagues are involved. With colleagues, I mean book writers. Be surprised what you see. So at Friday, for 1 week, you can have around 15 books, 10, 15 books, with a significant coupon, and the money will directly go to ALS research. This time, I will give it to digital research. The idea of digital research is to try something out digital, see what could have a potential, and then do it with a trial. Therefore, you can do way more in a short time. Because we are now in a time where we can expect the first significant improvements.
All right. So we have a question which I copied from Hobido to LinkedIn because it's too long and cannot display it in StreamYard. But if I bring it in here as from LinkedIn, then it works. With futures and promises, the thread that has the future is relying on the thread that has the promise to return and not hang. Do you see a use case where a thread should be able to kill a worker thread?
Do you see a use case? I have issues with killing a thread. Why? First of all, we cannot do it in C++ 20. And second, you don't know in which state the thread is. Maybe it's holding a lock. And now killing it would be terrible. What we can do in C++ 20 is cooperative interruption. Meaning, you can send a signal to a thread, or let's say a promise. And the promise can react to it by saying, for example, I'm done. This means cooperative interruption. By the way, one who implemented this feature was Nico. So let me bring him in. So this is what you can do. Use cases. Maybe you search for a prime number. And when you have the first one, you say to the other threads, stop your work, because you only want to have one. So there are use cases.
Yeah. think
And this
there's
can be done pretty elegantly with cooperative interruption, which is essentially only a signal mechanism.
yeah, I probably agree with that. It's like for me, I don't see that you programmatically kill a thread, and in a way, it's like maybe like you start two threads and one of them is faster and you kill the other one because you already have the result, but that's not like what most people do, right? And they're like in their programs.
Let me say it this way. It's possible in piece threads, but it's mentioned, you should not do it. So it's part of the piece threads API, but not of the thread API. We cannot kill a thread.
So, I mean, the one use case I have for that is testing. That you write a test where you kill a thread, and you maybe you have you want to see what your system is doing then, and
Okay,
that could make sense. But in production code, I don't see it. But already like doing this as a test case is very contrived, because that's basically going out of the bounds where your program should be happy with. You've also mentioned like that there is like on next Friday, when this video also will be live on YouTube, there will be C++ books, and maybe we should quickly also talk a bit about your C++ books. And do you currently plan to, or are you working on a new book, or
not so far. The only book I'm always thinking about is Introduction into Templates. I think this is still missing, but I don't have time to write now one. Similar such as my introduction to coroutines, not to coroutines, to concurrency. Because I think the book of Anthony Williams is extremely good, but it's already advanced. What is missing is to write a book which brings the beginner to this level to consume Anthony's book. And the same goes for templates. The book from Nico, Doug Crater, and David Vanderwater about templates, it's extremely good, but way too advanced for the beginners. We need a book which fills the gap from beginner to advanced. This is what's often missing in C++. We don't have these books. We need books to fill the gaps. Not only advanced books. And therefore, we need such kind of book.
That's true. But writing books is difficult.
Yeah, of course.
All right. So I think with that, we have reached the end of questions from the audience. Oh no, wait, there's a question. There is a question on books, which is on books. What's your opinion on what should be the maximum number of pages a book should have?
What should I do with this question? I don't know. Honestly, let me put it differently. I wrote 2 books about, including 17, the core language, about, including 17, the library, C++ library. Why? Because the excellent book from Nico has probably 1,200 pages. this is too much for a beginner. Our goal must be to explain our story in way less pages. Therefore, I try to write shorter books, which I cannot always achieve. But I wrote about core language in 300 pages. I wrote about the library also in 300 pages, but not in 1200. Once more, Nico's book is extremely good, but this is not a book for the beginner. Also, Bjarne's books, more than 1,000 pages. This is nothing for a beginner. You cannot learn a language which has more than 1,000 pages. You should start with 200 pages. And then you should dive deeper. So my point is, explain your story as concise as possible, but not shorter. This is my idea. I failed in my clean code book core guidelines. But my book about the core guidelines is way shorter than the original, at least. My idea is read it from the beginning to the end and you are done. And this is for me the right length of a book. Because what many people forget is my job is also to provide you the essential material, not all material, the essential material. And I'm the filter for you.
That's true. I've heard from a different author that they had a page limit, so they had to they had more material than was fitting in the book.
I know the book, by the way. I know, by the way, the book, because I know whom we're talking about.
That's possible. There's many authors which both of us
Yeah, but
know.
I know this discussion.
And I know that you went for self-publishing, and other authors did that too a few years ago. And I think you're still happy with that decision.
This is a pretty good decision because it's your book. You can do whatever you want. And then when your book is good, other people will translate it in different languages.
With that, we are through the part with the questions. Thank you for coming, Rainer. It was really a big honor to have you, and also great to
Thanks
see
a lot, yeah.
Things are good with you, and that we're able to keep going and see a lot of contributions from you even in the future. Because that's like really, really, you're one of the big contributors to C++ in the order of explaining. And I want to just thank you to that.
I only do what I love, to make it simple.
Okay. So with that, I'm going to take us offline. Thank you to the audience.
Bye.
And